Welcome to another GeoLibre tutorial. In this video, I'm going to show you how to regularize building footprints in the browser with GeoLibre. It's blazing fast because it's built on top of Rust. And it's very easy to use. You don't need to install anything. All you need is just open the browser and then just select your input data. You'll be able to get regularized buildings easily just with a couple clicks. And first, I'm going to show you the demo. If you go to the link in the video description below, you can see this map, compare them side by side. So beneath, you will see the satellite imagery, and then we have two building footprints. This is particularly useful if you use deep learning to get building footprints. You might end up with something like this, especially, for example, this along the diagonal line. Those buildings are actually quite challenging. You might feel that it's very easy to do, like simplify the building outlines. It's not. It's a very challenging issue, and one of the most popular tools that being used is the ArcGIS building regularized building footprint tool, but that one is not open source, and there are a couple of other open source options out there. You will need to install quite a decent number of dependencies using Python, and the result is not always optimal. So in this video, I'm going to show you how to use just the browser, and it's fast, it's easy. First, let me show you the result. Okay, so this is the blue polygon here, is the original building footprint, and this is the one that we simplify. So you can see here, there are a couple options you can control right now. It allows, for example, right angle and also diagonal line. So that means you can have some not perfectly right angle because you want to simplify the data, but in the meantime, you also want to minimize the changes so that you can preserve the shape. And it depends on the location. For example, if all the buildings are basically horizontal and vertical, you don't really need diagonal line, then you can have set the right angle. But if your building is kind of complicated and also the shape is, the orientation is all kind of direction, then you probably want to have some of this diagonal line. And I'm going to show you how to do that. Again, you're welcome to try this one out. And this is the result that derived from deep learning. And then I just apply this regularized building footprint tool. And then it works perfectly. You might see some missing buildings here. This is not really the problem of the regularized building footprint. It's more like the area imagery used to delineate the buildings. But once you get the buildings, you can simplify them really easily just using a tool. So I'm going to show you how to do that. First, you can go to the website web.geolibre.app. So this is a new cloud native GIS platform that I've been working on for the last 2 months, and it has a lot of functionalities. Today, I'm just going to show you one particular tool because it's the one that's kind of highly requested and also something that's useful for deep learning. I'm going to show you how to use that. So if you go to the website here, and once you open it, you will see the globe. First, you want to add a satellite base map. For example, you can click the button here, upper left corner, base maps. And once it's open, you can search any base map. For example, I can add the Esri wall imagery here. Just click, and then you should have this base map showing up here. You can click again to remove the plugin icon. And once you're here, you can just start adding vector data. Or if you want to see the label up right here in the style panel, you can turn on this box, show base map layer, and then scroll down to maybe find, let's say, airport. So in that way, the label will be showing up on top of the map. So in that case, you can see the location. Next, you will need some sample data. If you have your own data, that's great. If not, I also provide the link in the video description, so you can download some sample data to a computer. This is hosted on Source Co-op. I have some sample data here: net building, mass, UTM, or you can have the original WGS 84, so basically just the latitude and longitude. And because we're doing the regularization, usually you want to use something that with a projection, so you can control, for example, how many meters that you want to simplify, because you can set a threshold. So I recommend to use this one, although the other one also works, but I want to use this one, the UTM projection. And once it's open, you can click the download button, and you can just right click, save this one to your computer here, for example. Okay, and once it's done, you can go back to here, and then you can just drag and drop the file to the browser here. Just you can see the original data. So under the hood, it's going to do the reprojection. It's actually being converted back to WGS84, but now the data has been rendered. So you can see here, this is exactly what I showed you earlier, compare them side by side. Next, let me show you how actually you can do the regularization. What you need to do is go to the processing menu and then go to vector, GeoLibre. So here I have added like 4 tools. So these are the tools that build on top of Whitebox, but I added additional tools that are not available in Whitebox. So for today's video, I'm just going to use this one, Regularize building footprints. Once you click on that, it's going to pop up the Whitebox interface. From here, you can start selecting a file. And what I recommend is to do not select from here, because even this one is UTM. Even it says UTM, just the layer name, but when you plot this one on the map, it has already been converted to WGS84. So you probably don't want to use this one because the result is not as good. I can show you what it looks like. So for example, if I select this one, and then I can show this one maybe right angle or diagonal, whichever you prefer. So for example, I can just select maybe the how about this, the right angle, and then the reason for this is the maximum distance. This one is in the CIS unit, and this is basically 1 degree. It's just too big, so the result, it might not be optimal. I can show you, like if I click run, and then you get the result just less than 1 second. So you see here, these are the issues. This is initial result. Okay, it looks like this. It's not very good, but actually it's not the problem with the algorithm. The problem is your projection. Okay, so now let's try this one again. You can go to processing, go to there again, or you can also go to the history. Okay, once you go to the history, you will open this tool that you just ran earlier, then click this edit and rerun. All right, once I'm here, I can select file. I will select this one from my computer. So I'm going to select here UTM. So this one preserves the UTM projection and it's much more precise. Now I can just select here, and then I can select maybe right angle and diagonal. Okay. And for this one, the default, for example, this is UTM projection. The unit is meter, so I can keep 1 meter, or you can change to a different value. And there are also other parameters here you can customize, unless, I mean, this is for building footprint, so usually you don't have to do that. But if your data have a lot of circles, you can also adjust the circle. For example, the smallest allowed, the largest allowed, something like that. But in this case, we don't really have those, so I'm going to keep this as default. Now let's run this one again. Just click run, and let's compare the result. See here, let me turn up the original one, and this is what we have right now. Is it so much better now compared to the original one? I can, on the right here, let me change the color. For example, I may switch to transparent, and I'm just going to use the outline color red. So now you can see the differences between the initial one using the WGS84 and the new one. Of course, right now we're using diagonal, so you will see some of this, but you can change it to just the right angle as well. And then I can turn on the original one. So let me turn off the previous one. So look at this. This is exactly what I showed you at the beginning. It looks much nicer, and you can see if there's any artifact. But overall, this is the one that I have tried. I've tried different tools. This one by so far gives the best result. If it doesn't look good, you can adjust the parameters, but overall it should be pretty decent. So for example, here this one also allowed the right angle and also diagonal. If you don't want the diagonal, you can go to here. I'm going to edit, run this one again, and so make sure you select the file again. From here, I can just choose just the right angle, so I don't want a diagonal. You will see some differences. So again, click run, and it's done. Now I'm going back here. Right, so if your data has a lot of like orientation, then sometimes it the right angle, it might shift the orientation a little bit. So if you see this one from here, right, so this is original one, and this is the right angle one. It does shift it a little bit, but if you only want right angle, this is something you can certainly do here. So you can compare the result. I mean, either one looks pretty decent. So for example, this one here, maybe I prefer just with the diagonal line here. And you might see that the building outline does not perfectly align with the raster. That's not the problem of the algorithm. Okay, that's the problem of the deep learning algorithm. Also the image that we use to do the detection. But you get the idea. So you can easily simplify or regularize the building footprint just using the tool. And you can see here it's super fast, less than 1 second. You don't need to install anything. It runs entirely in your browser. And the other thing I want to mention here is that you can also copy the link. So for example, if I open this one and there's a button here, copy the link. So that means you have a tip link that you can send the link to anybody, right? So if you want to share with other people that they can use this one, for example, the building footprint tool, you can just copy the URL and then paste the URL in the browser or send to anybody. It will open the file, the tool directly, so that you don't have to navigate to find where it is. Of course, you're welcome to source the box here, regularize, and then select this one. But any tool works. So for example, here I can extract a code, and here I can pass in even the URL. You also have the URL. Let me show you. For example, I can add a DM. Maybe I can add a raster here, and I will maybe show how about the link cover data, for example, right? And it should open this one. Let's say, okay, I want to extract the a subset of the raster. Then I need to use the tool. So if you want to show other people how to utilize this one, I can go to the processing and then whitebox. Okay, so from here I can source the code and extract code subset. From here you can maybe just passing the URL. So for example, you can give a URL. I don't know that. Let me open this one. There should be a URL here. For example, I can just copy this URL and then go to the processing tool here. Okay, from here I can just select this one. All right, and I can just draw a map. So I'm going to move this one around, maybe somewhere here. Let's say I want to extract the urban area of Las Vegas. So I select this here, and then it's pretty much it. You can just click one. It should be able to extract the raster as a subset of the code. And if you want to share with other people, just copy this URL. Okay, it's done there. I'm just going to copy the URL and then send to anybody. You will see the URL encoding all the parameters and also the URL. So if you can enter, for example, if I share the link, if you click this link in the video description, you can just click the one, you don't have to provide all the parameters. So it's very, very convenient. And let's take a look at the result, right? So we just do the extraction, and this is subset. See how cool it is. If you zoom out, you might see some artifact like looks like black color, but if you zoom in, everything works just fine. So you can basically extract any data from any cloud optimized GeoTIFF just using the browser. You don't have to install heavy pack dependencies. And right now, the WhiteboxTools, if you see from here, it has 757 tools. There are tons of tools you can already utilize. And I'm also actually right now expecting the toolbox. I think it holds over 780 tools right now. So the project GeoLibre-Rust. Keep building this one. So you're going to add more and more tools. So next time if you see it, you will get a lot more. And I'm integrating some of the tools from ArcGIS. Basically, we implement those using Rust. So it's much faster. These are some of the tools that I already added. So it's already a lot of tools. If you want to see the latest one, you go click here in the upper right. This one is going to show you all the tools, and it's 782 tools available. Compared to the one here is 757, so it's on more than another 25 tools that I just added yesterday. Again, it will be integrated into GeoLibre very soon. And if you click these GeoLibre tools here, these are the 50 tools that's available. And Regularize building footprint is one of those that are added. So all the tools that developed in here, you'll be ported into GeoLibre. So you're going to enjoy the full power of geoprocessing in the browser without having to install anything. And I hope you like it. I hope you find it useful. You are welcome to explore more tools in here. I don't have time to go into the detail, but this is the most powerful platform that I've ever created. And it can empower you to do a lot of geospatial data visualization and also data analysis just using a browser. Of course, you can install the desktop app if you want to. Go to the GitHub repository, and then from there you can install, for example, on Microsoft Store. I have updated to the latest version, so this is version 2.2. So just install that from your Microsoft Store, or if you are on Mac computer, you can use a homebrew brew install GeoLibre. You get the latest version, or if you are on Linux, it's also available. It also has the Android app. I'm actually trying to publish one on the Google Play Store. Hopefully, right now it's under review. Hopefully, it will be published in the next couple of days. And then you will just install that one click by searching the Google Play Store. But you'll be able to find the releases, all the files, under the GitHub releases here, 2.2. And if you scroll down, you can download this one, whichever packages for your operating system or for your phone. Then you can install to utilize them. Looks like Mac OS M series is the most popular, and also Linux computer or even Windows. Okay, that's all I want to show you. Again, if you enjoyed it, give a thumbs up. I will see you in the next video. Take care. Bye bye.